And with computer audio. Okay. All right, so I'll open up the attendance. Okay, so attendance is open. So you can go ahead and click in if you are present or if you are remote at home. All right, and I'm going to try something new today where I have the chat up on my laptop. So I'm not sharing the screen with the chat. So if I miss looking at the chat, would somebody please tell me? Y'all have to stay on top of me and keep me from missing anything. The first thing I want to say is that y'all did really well on the exam. The average score was a 75. So y'all did really well. I'm very proud of y'all. We had some high scores, and I think y'all worked really, really hard to get the scores that you did. So I'm very proud of you for your hard work. There was something else I wanted to tell you before we started, and I don't remember what it was. I know I told the last section something else. I'll think of it. But, oh, the other thing I wanted to tell y'all. So y'all know we missed a week for the hurricane, right? And I know that there are some classes who are making up nights or weekends, making up time here. That's not how we're doing it. I gave you an extra lecture over the weekend because we had a 3-day weekend, so we had a little more time. That's your extra class period. Okay? I'm not coming in at night for the weekend. I do that. we all have lives. You have jobs. You have kids. You have no. So you got your extra lecture. All right. So we're good. All right. So our next exam is going to be chapter 3, chapter 4 for sure, and however much we get through on chapter 5. I'm only going to test you on what we cover. I'm not going to only cover half of chapter 5 and put the whole chapter on the exam. Okay? But whatever we do get through, that's what's going to be on the exam. So if we happen to get through the whole chapter 5, great. If we don't, it's okay. It'll be on the next exam. All right? Questions about that? You okay? Good. All right. So you should have watched chapter 3, sections 1, 2, 3, and 4, right? Before you walked in the door today. And then tomorrow, well, between now and our next class period, you're going to watch 5, 6, and 7, right? And you'll know where to get the calendar. You know where to see that. So for this chapter, I tried putting a link for every single video instead of doing the one link to the playlist. If y'all tell me what's better for you, I'll do it that way, but I've never built a Moodle class before, so I'm learning as we go too. So if you find something that works, hey, this was really a whole lot better than the way you did it before, tell me, so I make sure to continue to do it that way. Or hey, Dr. B, it was easier when it was just a playlist. Just tell me, okay? I'm flexible. All right, I think that's it. So you should have checked in that you were either present in the classroom or remote at home. So I'm going to stop that poll, and I'm going to close this, maybe. All right, so I'm trying something a little bit different. So hopefully this all works. It worked pretty well last period. Last class, I didn't have any problems with the drawing on the screen like I have in the past. Okay, so first things first, we're going to review a little bit of what you should have watched in the video. So y'all ready to get some more clicker points? Because remember, your class average right now does not take into account your clicker point average. So if you have a 70% or above, that gives you an A for your clicker grade, but I'm not going to incorporate that until like the end of the semester. Okay? Somebody got feedback going? Let's try that again. All right. Okay, so clicker questions, y'all ready? Let me move that. All right, how many protons and electrons are present in the sulfide ion S2-? I'll give y'all a minute. A periodic table would be a super helpful thing to have. Maybe I'll give y'all a minute and a half because y'all got to go get a periodic table. Okay, 15 seconds. Make sure if you don't know that you guess. Don't leave anything blank. 5 seconds. All right, so how many protons and electrons are present? Let's see what we said. Oh, good. Let's see, how do I do this? All right. So we should have 16 protons and 18 electrons. How did you figure that out? You got out your periodic table and you went to go look for what? The atomic number. The atomic number tells us the number of protons, and in a neutral atom, it tells us the number of electrons. Yeah. It was a long weekend. Y'all should be refreshed and excited, right? All right, so in a neutral atom, we have 16 protons and 16 electrons. But do we have a neutral atom? No, indeed not. We have an S2 minus. What does that tell us? What does that 2 minus tell us? We had to add 2 extra electrons to have an overall -2 charge. If you changed your number of protons, what would you do? You would change your element, right? If you change your atomic number, you change your element. So you can't do that and still be sulfur. So we have to change our number of electrons. So we know that we have 2 more electrons than protons. So if we have 16 protons, we must have 18 electrons. Okay, let's try another one. What ions are formed when magnesium transfers electrons to chlorine? Give you 1 minute. Maybe a minute's not going to cut it. A minute and a half? Yeah, a minute and a half. All right, calling it. All right, so what did we say? Ooh. All right, so what we're looking for is C. How did we figure this out? Well, let's take magnesium first, right? Magnesium transfers electrons to chlorine. So let's take magnesium first. When you go look on your periodic table, where did you find magnesium? You found magnesium in the second column. So what group is that? Group 2A. So if you're in group 2A, what does that tell you about your number of valence electrons? You got 2 of them, right? So here's your choice. You want an octet. Everybody wants an octet. An octet is 8. How am I going to get to 8 if I only have 2? I could gain 6, or I could lose 2 and have an octet in my lower energy level. What do you think? Is it easier to lose 2 or to gain 6? Lose 2, right? Path of least resistance. I'm just going to lose 2 instead of having to gain 6. That's a lot of work. Energetically, that's a lot of work. So I lose 2. If I lose 2 electrons, now I have 2 less electrons than protons. So I now have 2 more protons than electrons, and I'm going to be a +2 charge. The opposite is true for chlorine. Where do I find chlorine on my periodic table? In group 7A or 17, either way is fine with me, right? So we're in 7A, so we have 7 valence electrons. 2 choices. You're going to lose 7 or you're going to gain 1. path of least resistance. Gain one. We're just going to gain one little old electron. If we gain one electron, now we have one more electron than proton, so we're going to be a charge of -1. Do we write the ones? No, they're understood. Okay. All right. Select the correct match between the name and formula unit. I'm going to give you about 2 minutes because you kind of got to work through them. So I'll give you 2 minutes. About 30 seconds left. All right, ooh, went over time. Okay. So what did we get? So what you should have gotten was B, magnesium sulfide. So when you do this, you identify the charges just like you did before, but when we have Mg2 plus and we have S2 minus, what do we do with those charges if we want to make a compound? We have to cross them because we want our overall ionic compound to have a charge of what? Big fat 0, right? So how are we going to make that happen? Well, it works perfectly if you just do the crossover, but that's not all you have to do. It's the crossover and what? Reduce. So Mg2S2 reduces to MgS. Okay, so what that's telling me is if my magnesium is a 2 plus charge, I have one of those, and I have a sulfur ion, that's a -2 charge. If I have the 2, then I'm going to have a net overall charge of 0 because one's +2, one's -2, right? 2 minus 2 is 0. So that's the only one where that works. All the other ones, they were incorrect. Crossing over, you know, all that kind of stuff, but an incorrect formula. Okay, so that's just a little kind of reminder of what you should have covered in the lecture videos, and it's not quite all of it, but if we have some time at the end, I'll come back and we'll pick up some more. Clicker questions. Okay, so I'm just going to kind of stick that up there. All right, so you should have a periodic table. I stuck one at the beginning of your in-class problems so that you would have it. And I'm learning this, so I have to go to the next page. Okay, so the first thing we want to remember is how electrons are organized inside of atoms, right? And so electrons are organized in that in our principal energy levels. And our electrons want to go into the energy levels that are closest to the nucleus first, or the lowest energy level. So what's the lowest energy level? Energy level 1, okay? Energy level 1 is unique. Why is it unique? It can only hold 2 electrons, okay? So that's one thing you need to keep in mind throughout this entire exercise, right? So we want to know how many electrons are in each energy level for the following elements. Hydrogen. I want you to first go to your periodic table and tell me what is the atomic number of hydrogen. Atomic number of hydrogen is 1. And I know in a neutral atom that the number of protons is equal to number of neutrons. So my total number of electrons is 1. So my 1 electron wants to go in the lowest energy level possible. Where's it going to go? First, second, or third? First. Tell me about fluorine. What is fluorine's atomic number? Fluorine's atomic number is 9. Now, my electrons want to go in the lowest energy level first. My lowest energy level is energy level 1, but how many can I stick in there? Only 2. But I have some left, right? How many do I have left? 7. Where do they go? Second energy level. Okay, argon. How many do I have? 18. Well, let's fill our first energy level first. That's 2. How many do I have left? 16. Is 16 going to fit in our next principal energy level? No, but I know I have at least 8. So 8's going to go in that second energy level. What's going to go in the third energy level? The other 8. So make sure that all of your electrons add up to your total number of electrons. So just one thing to kind of double check. Okay, potassium. How many electrons? 19. Okay, so how many go in the first? 2, it can only hold 2. How many go in the second? 8. How many do I have left? 9. So we're going to put 8 in that third energy level. Then we're going to go up to the fourth energy level. I'm not going to give you any in the fourth energy level because it starts to get kind of wonky, and I'm not going to do that to you. So really, I'm going to stay in the third energy level. Okay. All right, so now we know about our total number of electrons. We know how they go into energy levels. But what are the important electrons that participate in chemical reactions? Valence electrons. Valence electrons are the ones that control how an atom behaves. So that's the one we need to be really, really clear and know how to identify. So how many valence electrons are present in carbon? Before you answer, I want you to tell me what group each element is in. So tell me, what group is carbon in? You could say group 14, or you could say group 4A. Either one's fine with me. So how many valence electrons does any element in group 4A have? Oh, this is so nice. VE, not EV. 4 valence electrons. That's the abbreviation for valence electrons. Okay, aluminum. What group is aluminum in? Group 3A or group 13. So how many valence electrons? 3. Lithium. Group 1 or 1A. How many valence electrons? Can all the problems like this be on the exam, right? All right, fluorine, what group? 7A or 17? So how many valence electrons? 7. It can, but because of sublevels, it goes into 4 first. It goes into the B. But we're not going to go into the B. Don't worry about it. I'm not going to give you any pass-through. I promise. I won't. It goes into the D, so they're not valence electrons because they go into the word D instead of. It's okay. You don't have to. Okay. Okay. So which of the following elements are stable as out of the question? You don't have to know SPDF. You don't have to know SPDF. Yeah. Well, we'll talk about it a little bit, but not in the way some of y'all probably know. So you don't have to worry about it. Okay. So which of the following elements are stable as atoms? Tell me what gives something stability. A full valence shell. That's stable. Now, we want to say octet, right? That makes it easy. And for most elements, that's true. So most want an octet. And an octet is 8. But we have some exceptions. Who's happy with 2? Hydrogen and helium, right, want a duet. A duet is 2. So be careful with that. Most do want an octet. Everybody wants to be like those noble gases. Everybody's jealous of the noble gases, right? They all want to have the octet that the noble gases have, except for hydrogen and helium. So just keep that in mind. So let's look at this. Which elements are stable? Beryllium. Is beryllium stable, and why or why not? It's not stable. Why not? What group is beryllium in? It's in group 2A. So tell me about all the elements in group 2A. They have 2 valence electrons. It's 2, it's a duet. Is that good? Why not? What does beryllium want? It wants 8. The only exceptions are hydrogen and helium. Okay, argon. What group is argon in? So how many valence electrons? Are we stable? Yay, we're stable. So argon is stable. How about fluorine? What group is fluorine in? Group 7A. So how many valence electrons? Are we happy? No, we're still kind of sad. How about xenon? What group is xenon in? Group 8A. How many valence electrons? Ooh, are we happy? Absolutely. Okay. All right. Now we're going to talk about how do we get to that octet, right? So we're going to form ions to get to the octet. So tell me, what's the difference between a non-metal atom and its anion? A non-metal atom and its anion. So the non-metal what's a property of that? If it's an atom, what can you tell me about it? It must be neutral. So how do I become neutral? My number of protons must what? Number of electrons. All right? So how about our anion? What happens with our anion? If we're a non-metal, let's take an example of a non-metal. Let's do fluorine. Fluorine's our atom. What's our anion of fluorine? The fluoride ion, which has a charge of what? -1. How did it get that -1 charge? How do you become negative? Can you lose a proton? You gain an electron. So the anion has gained one or more electrons. Why has it gained one or more electrons? To complete what? Its valence shell. So if you watch the video, tell me on the periodic table, what element does fluorine look like in terms of its electrons once it gains that electron? It becomes like neon, Ne, it becomes like neon. Is that what it wants? Yes, because that's a stable electron configuration. Okay, so everything, when it gains or loses, is going to end up looking like a noble gas, right? Those are the things that everybody's jealous of, right? Okay, 310, how are the names of transition metal atoms and its cation different? And I'm going to add to this. I want to know a regular metal, a transition metal, and then its cation, right? So we're going to add a little bit to this. So if you have a metal and you have its atom, what are you going to call it? Just the element name, right? Element name. How about if you have a transition metal? What do we call it? If it's just the atom, just the name, just the name. So element name. Okay, now, what if we switch and we say a metal cation and a transition metal cation? How do we name those two? Let's do the metal first. Can I just say, if I have this, can I say that's magnesium? That's not magnesium. That's the magnesium ion. So it's the name plus the word ion. So that is the magnesium ion. This is the magnesium atom. What if I have a transition metal? What if I have this? What do you notice about where it is on the periodic table? Fe. Where is it? Number 26. It's in the middle of the periodic table. So all of this stuff in here is our transition elements. So if it's a transition element, what do we call it? We start with the name, and then we put what? Roman numerals in brackets. So Roman, not brackets, in parentheses. Numerals. Roman numerals for the charge, right? And are we good? Iron 2 ion, right? So this Fe2 plus would be called the iron 2 ion. You okay on that? Oh, I know what I was supposed to tell y'all. I wanted to tell you that I added some stuff to Moodle for you, and I want to tell you about it before I forget, because I am liable to forget. Okay, so when I posted stuff for chapter 3 here, I put you an extra link for the calendar. It's the same link. I posted you the lecture slides, the in-class problems, and it's loading. Of course it's loading. Okay, those are the videos. But what I did for you at the bottom is I posted you, some people ask me, can you post additional videos? Like I need extra practice with one thing or another. And so I tried to pull some extra resources for you from most of the chapters. Okay, so they're not required, but they're there for you if you want them. That's the other thing I really wanted to tell y'all. I knew it would come to me eventually. Okay, switching gears again. All right, provide the charge when an ion is formed from each of the following. Sodium, what group is sodium in? In group what? 6A. Here's 6A. Sodium's in 1A, right? In group 1A. So if you're in group 1A, how many valence electrons do you have? So are you going to lose that valence electron or are you going to gain 7? You're going to lose your one valence electron. What's your charge going to be? I'm going to be Na. If I lose one negative charge and I was neutral to start with, what am I now? I'm a positive 1. Do we write the 1? No, we just leave it. Okay, phosphorus. What group is phosphorus in? Group 15 or 5A. How many valence electrons? 5 valence electrons. What's going to happen? Am I going to lose 5 or am I going to gain 3? I'm going to gain 3 valence electrons. So now I'm going to be P, and what's my charge? I'm going to be 3 minus, or minus 3. You could do it either way. It does not matter to me. I don't know if it matters to the homework system. That's a good question. I need to look that up. I need to figure out if it matters in the homework system. If anybody tries it, tell me what happens, because sometimes what I see and what y'all see aren't necessarily the same thing. But we'll try. Okay, magnesium, what group? 2A, so how many valence electrons? We're going to gain 2, we're going to lose 2, or we're going to gain 6? We're going to lose 2. Remember, pick the lower number. We're going to lose 2. So now what are we going to be? Mg 2 plus, because we lost 2 valence electrons. Fluorine. What group is fluorine in? Group 7A. So I have 7 valence electrons. Am I going to lose 7 valence electrons or gain 1? I'm going to gain 1. So what do I get? F minus 1. So I'm gonna give you a suggestion. Can I scroll up? Are y'all okay? I'll come back. When you're, oh, I can't scroll up, but I can click. All right. When you have your periodic table, when you take your exam, you're gonna get a clean periodic table. So there's gonna be nothing written on it. But what you can do as you work through these problems to try and help you remember is to put the charge on top of the column. So for group 1A, what charge could I put on top of that column? Everything in this column is going to be a +1. How about in group 2A? Now, these are going to vary, right? And so we have to use those Roman numerals for them. So we're not going to put a charge there. How about 3A? How about 4A? 4A isn't really going to make ionic compounds. And we'll talk about that when we talk about covalent compounds. So how about 5A? -3. So what do you see? What happened? We changed from metals being plus to non-metals being negative. So -3, what's 6A? -2, 7, -1. How about group 8? They're good. They don't want to change. They're happy. They have their octet, right? So could you use this as you're doing your homework? Yes, but are you going to have a periodic table that has the charges listed on it for the exam? Yeah. So be careful. Don't use it as a crutch. Okay. Did we finish this page? Yes. All right. So 3.14. How many protons and electrons are present in the following ions? So we're going to say P plus and E minus. I can kind of, those are terrible lines. Wow. All right, and I want you to tell me also the atomic number. Okay, so what's the atomic number on aluminum? 13. When I become an ion, do my number of protons change? Nope, or I would be a different element, so I have to still have 13 protons. But I have Al3 plus. What happened for me to get a charge of 3 plus? I had to lose some negative to get a positive. So I'm going to lose 3 electrons. So I'm going to lose 3 electrons, and what's my charge going to be? What's my number of electrons going to be? I'm sorry. 10. Right? Because I started out with 13 and I lost 3. Okay, Br minus, what's its atomic number? 35. So that means I must have 35 protons, and I'm going to start with 35 electrons. But what do I do to get a negative charge? I'm going to gain electrons. How many? I'm going to gain 1 electron for a total of how many? 36 electrons. Do y'all see where I'm getting that electron number? Okay, let's try another one. Hg is mercury. What's my atomic number of mercury? 80. So how many protons do I have? 80. Okay, and how do I get that plus charge? By losing 1 electron. If I lose 1 electron, and I started with 80, how many do I have? 79. N3 minus. So nitrogen has an atomic number of what? What is it? 7. So how many protons? 7. What am I going to do to become a -3? I'm going to gain 3 electrons for a total of 10 electrons. When you have your scratch paper for an exam, you can write that stuff, right? It's your scratch paper, right? Whatever helps you. Okay, so now we have to name our ions. Now we have to apply those rules. Al3 plus, what are we going to call this? Shout it out, anybody. Aluminum ion. Br minus. It's bromine, but because we're negative, we're going to add the IDE ending. So we're going to be bromide, IDE. Do we have to put ion? No, because we did the IDE. Hg plus. Mercury, M-U-R-M-E, I cannot spell. M-R-Y, Mercury. Where did you find mercury? And those transitions. So we have to put in Roman numerals in parentheses what the charge is. Mercury 1 ion. Okay, N3 minus. Whenever you see that minus, you should automatically think, I need to add an ide. So it's not nitrogen, it is nitride. Nitride on my chemistry exam. Yes, sir. Oh, thank you. Can you explain why it's kind of backwards? Like Al has a 3+, but it's losing those electrons. Because, Caitlin, you're starting, if you're aluminum and you're a 3+, right? You started off, if you're aluminum, how many protons? What's your atomic number? It's 13. So when you start off, aluminum has 13 protons and it has 13 electrons. So that's saying you have plus 13 and you have minus 13 for charges. What are you overall? 0, right? But if I'm told I have Al3+, I need to change my overall, right, Al3+, to get to a -3. Can I change my number of protons? I can't change my number of protons, so that's still a plus 13. So how am I going to get an overall -3? I need to have 3 more electrons, so I need to have negative what? -16, so that I would have 13 protons and 16 electrons. So I had to gain 3 electrons in order to have an overall charge of -3. Does that make sense, Caitlin? All right. Okay, so let's see, what are we doing now? We did 3.16, and I accidentally did them out of order, right? So we'll do 3.20. Name the following ions. Cu2+. Where do you find Cu? Transition, so be careful with that. Transition, how should I name it? I should name it copper. It's a transition, so I'm going to take that charge and I'm going to represent it with Roman numerals as 2. Copper 2 ion. Now, what do you notice about B and C? We have multiple different elements within the same formula, right? So in B we have sulfur and oxygen, in C we have hydrogen, we have phosphorus, we have oxygen. So both B and C are polyatomic, right? You have atoms of different elements inside of this one ion. So are you going to find these on the periodic table? No, you need to go find it on the polyatomic ion chart. And it's in your textbook, and I promise, the polyatomic ion chart will be, guess what? Provided on the exam. And I just typed a T in. I guess my watch hit it. I don't know how to get rid of it, so we're just gonna leave it. All right, so that's like Christmas come early. You don't have to memorize polyatomic ions. Yay! I should be a little more excited than that. All right, so it's super difficult to name these polyatomic ions, right? I mean, like you got to go to the table and find it. That's it. That's all. So go find SO4 2-. Just be careful that you match the right little subscripts because SO3 is different than SO4. So look on your online textbook, on the printed out notes, what is SO4 2-? Sulfate. Because remember there's 8 and ite. If you see 8 or ite, you know that it is a polyatomic ion. How about HPO4 2-? And if you don't have one with you right now, it's okay. Just know for your homework where to go to get it. Okay, so HPO4, anybody? Hydrogen phosphate. Do you see that 8 on the end? That's telling me that that's a polyatomic ion. Okay. All right, now we are going to name some compounds. And what I realized after I did this and sent this out to everybody is that I didn't give you nearly enough room on this part. So I apologize. I'll try to do better next time. All right, so 3.22, we're going to give the formula and the name. So potassium chloride. Tell me what are my two ions. Let's start with that. Potassium is what letter? K. It's an ion, so what? It's in group 1, so it's going to be +1, so I'm just going to put a plus. Chloride tells me it's an ion. It is Cl-. What's the trick? This is the trick. It's not the science behind it, but it's the trick. What do? You cross over and then reduce. So that's the rule. Cross over and reduce. So we're going to take the charges and we're going to turn them into subscripts, but we're not going to keep the plus and minus. So we're only going to keep the number. So it would be K1Cl1. But is that how we write it? No. How do we write it? Just plain old KCl. But we also have to name it. How do we name it? So for the metal, we just say the name, potassium. But now for the chlorine, we have to remember to do what with it? We need to put the IDE on it. So it's potassium chloride. Because that is for covalent compounds. So your prefixes are only for covalent. And the way that you can remember that is a covalent compound is nonmetals with nonmetals, whereas ionic is a metal and a nonmetal. So potassium, if you look on your periodic table, right, is the blue, and then chlorine is way over in the yellow. So anything that's yellow is your nonmetals. It's a good question. Okay, B, zinc and oxide. So what's my symbol for zinc? Zn. Where is Zn? You can say it. Where is Zn? It's a transition metal, but what do you see noted? The charge does not vary. I promise I'm not going to do that to you. But so what's our charge on zinc? Any guesses? Positive, it's a metal. Zinc, what? 2. All right, so what do we have now? Oxide. Oxide must mean it's the oxygen, but it's an anion, so what's my charge? 2-. So do your crossover, but just take the number, don't take the charge. Crossover again, take the number, not the charge. So what do we get? Zn2O2. Are we good? No, what do we have to do? We need to reduce it. So ZnO, because 2 is divisible by 2, right? So 2 divided by 2 is 1. You can do this with ionic compounds, that reducing. Why? But you can't do it with covalent compounds, so be super careful. If I have, watch, let me just come down here. I'm gonna add some space and right down here. If I have NaCl, what's the charge on Na? +1. What's the charge on chlorine? Chloride? -1. Okay, so when we have this, if I represent sodium as blue, right, as a blue dot, and I represent chlorine as this big red dot, okay? If I tell you you have some salt, that's what sodium chloride is, it's salt. Is that all you have? 1 atom of sodium and 1 atom of chlorine? No. If I give you a block of salt, whether that block of salt is microscopic or that block of salt is like a horse salt lick, right? Huge. It's going to be a repeating pattern of cation and anion, cation, anion, cation, anion, so on and so on and so on, right? And I could stand here all day, and I wish I knew how to copy and paste, and I don't know how to copy and paste. So I'm just going to have to like really quickly do the best I can, right? So that this would go on forever in any direction, right? For as big as your salt block is, whether it's microscopic or whether it's huge. So when I say I have one Na and one Cl, what am I really saying? A ratio. I have a ratio, TiO, a ratio of 1 Na plus for every 1 Cl minus. It's a ratio. And because it's a ratio, I can reduce it. You won't be able to do that with covalent compounds. And we'll talk about why that is on Thursday. Okay, back to what we were doing. Okay, where were we? We did zinc. Oh, we got to name it. We didn't name it. What do we name Z and O? I get on these side trips and forget. Zinc oxide. Because we just give the name of the metal, and then the non-metal, we give the prefix, the beginning of the name, and we add IDE. Okay, let's try the next one. Copper 1 and sulfide. So copper 1, Cu, you don't even have to go look at the periodic table, right? What's the charge on Cu? +1, because it's told right here. You have a Roman numeral 1, so it must be a +1. How about sulfide? S -2. So what do? We do our crossover, but you're only going to take the numbers. So what should our final formula be? Cu, 2, S, do I write the 1? Nope. So why did I need 2 copper ions in this formula? What do I want my overall charge to be? We've got 0, right? So if sulfur has a charge of -2, the sulfide ion has a charge of -2, how many copper atoms do I need to balance that charge out? 2, because it's only a +1. So if I have 2 negatives, I'm going to need 2 copper atoms, 2 copper ions, in order to have a +1 and a +1 for a total of +2, and then I have a -2 on sulfur, that gives me my 0. So that's the whole point. The crossover and reduce is just an easy way to get to that point, but you have to understand why we do it. All right, so, and name it. I want to keep forgetting to name it. What do we name it? Copper 1 sulfide. Copper 1 sulfide. Why would you need 2 copper? Okay, so let me come down here because I don't have room. So copper is a +1, right? Cu. Not, did I put C or did I put Cu? I put Cu. Okay. Cu is a +1, right? Sulfur is a -2. So if I look at the overall charge here, I only have a +1. Here, I have a -2. If I put 1 copper atom plus 1 sulfur atom, what would my overall charge be? +1 -2 would give me -1. So if I took another copper ion, now I have plus what? Now I have +2, and here I have, in sulfur, I have -2. So +2 and -2, now I have 0. Now I have 0. So it's all about balancing the charges. And if you just, the quick and easy, right? If it's +1, sulfurs, -2, the quick and easy is just to swap them. And you get Cu2S. But this is the real reason behind it. Okay? All right, let's see. All right, so we did a couple, okay, so now we're on 3.24. I really did not put enough space in there. All right, 3.24, give the number and each type of ion present in each of the ionic compounds that we did in 3.22. So I don't know if I can get them both on the screen. Okay, potassium and chloride. Y'all remind me what the formula was for A, potassium and chloride. KCl. Okay, so now tell me how many of each type of ion do I have? Let's start with the potassium. I have 1, because that subscript where nothing's there, what is that really? It's really a 1. So I have 1 K plus ion, or you have 1 potassium ion, however you want to say it. You could do words, you could do symbols, doesn't matter. And what? Tell me about my chlorine. How many chlorine ions do I have? I only have 1, and it is Cl minus, or 1 chloride ion. You can say it either way. Okay, zinc oxide, what was my formula? Zn, oh, come on, y'all did it. ZnO. So how many Zn ions do I have? I have 1 zinc, what? What charge is it? +2. So I have 1 Zn2 plus, or +2, however you want to say it, and what else? 1 what's my other element? Oxygen, but it's going to be the oxide. And what's the charge going to be on it? It should be negative. That's why we only need 1 of each, because zinc is 2 plus, oxygen is 2 minus, so we have an overall charge of 0. Okay, copper 1 sulfide. What was my formula? Cu2S. All right, so tell me, I have how many of copper? I have 2 Cu, what's my charge on copper though? +1. So I have 2 copper 1 ions and how many sulfur ions? 1, so as a subscript, it doesn't have a subscript, so that tells me it's 1. And what's my charge on it? It is -2, or 2 minus. It's like changing how you think about it. So you got to kind of like just change your brain a little bit to answer those. Questions on those? Okay. All right, let's see. Okay, so 3.26 is like 3.25. We have to give both the formula and the name for the ionic compound formed from the combination of the indicated metal, but we have to use the acetate ion in conjunction with that metal. Let's see if I can I erase? Yeah. Nope, that's highlighter. Oh, I can do it up here. I can do it up here. I want to make myself somewhere. There's got to be a quicker way to do that. We shall see. Okay, good enough. All right, so I want my sodium ion. So what's my sodium ion? Na, we're in group 1, so we're a +1. And then we're going to combine that with the acetate ion. The acetate ion, they tell you in the problem here, is C2H3O2 minus. What kind of an ion is that? That is a polyatomic. Okay, now what? That's like a -1. So now what are we going to do? Cross them over, right? Do we have to write the ones if they're just ones? No, NaC2H3O2, sodium acetate. Because all you have to do is give the name of the metal, and for a polyatomic ion, all you have to do is give the name of the polyatomic ion. So that's super nice. How about B? Fe2. Fe, put a 2 plus. Now acetate, we're going to write the same thing. C2H3O2 minus 1. So I'm going to do my crossover. 2 goes down here, 1 goes down here. So I'm going to write Fe. I don't have to write the 1. Now, C2H3O2. Now I have to also include this 2. How many oxygen atoms do I have? Do I have 22? No. I want 2 of this polyatomic ion. So how am I going to denote that? I'm going to put it into parentheses. So now, how many oxygen atoms do I have? I have 4. How many hydrogen? 6. How many carbon? 4. How do I name this? Iron 2, because that's telling me the charge, acetate. Oh, and I run out of room again. Okay, so it's aluminum and acetate. I'm going to come down. I really didn't give myself enough room. Okay, so what did I say? Aluminum and acetate, C2H3O2 minus. So what's my charge on aluminum? +3. So I'm going to cross them over. What do I get? Al1, but I'm not going to write it. C2H3O2 3. Am I done? I need my parentheses. How do I name this? Aluminum acetate. A-C-E-T-A-T-E, acetate. How are we feeling? Good? I like the head bobbing. It's good. Okay. 6. Right? We finished that page, right? Y'all have to help me because this is weird to go back and forth. Yeah, we finished that page. All right. Okay. So we're on 3.28, correct? Should be on 3.28. Okay. Give the number in each type of ion present. Oh, in 3.26. Tell me what was in 3.26? So A was sodium acetate, right? No. Yeah? C2H3O2. So tell me the number of each type of ion. So let's start with sodium. How many do I have of sodium? I have 1 sodium ion. Now I have to denote that it's an ion. So how do I do that? Na+. I could have said 1 sodium ion. Either one's correct. Either one. Okay, and what? Do I say 2 carbons, 3 hydrogens, 2 oxygens? No, I need to name the polyatomic ion. How many of that polyatomic ion do I have? I have 1. And 1 acetate ion. So you could do it this way, or you could say 1 acetate, acetate ion. Either way is correct. B. B was iron. 3O2, and it was a 2. So what do we have? 1 what? Iron, ion. How could I write that as a symbol? Fe. 2 plus. And what? Two acetate ions. I guess I'll do symbols. I'll do all symbols because we're doing that. C was aluminum. So I have 1 aluminum ion. What's my charge on aluminum? 3 plus, and 3, because that's my subscript here, 3 acetate ions. Yeah? I look so dead today. Sometimes it's hardest when you come back from a break. But y'all, it's going to be a long haul from here on out. It's going to be a long haul. I hate to be the bearer of bad news, but it is. It's going to be a long haul for everybody, so at least you know you won't be alone. Okay, Lewis structure. When we're drawing a Lewis structure, there are 2 different ways that you can do this. And either way is fine with me. Anybody, when you were watching the video, anybody else was taught the needed, available, shared method? Anybody? I guess it's not a very common thing, but I'll show you both ways today. That way, either way works for you. All right, so let's draw water. Let's do it not the needed, available, shared way. Let's draw our Lewis structure. So we're going to do A first. When we're looking for what our central atom is going to be, usually it's the first letter in the formula. But what's up with this formula? It starts with what? It starts with hydrogen. Hydrogen will never be a central atom, ever. Never, ever, 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 ever. So what's our central atom? It must be oxygen, because that's the only thing we have. So I'm going to put an oxygen, and I'm going to put my hydrogens on the sides of my oxygen. How many valence electrons does each hydrogen atom have? Only 1, so I'm going to give it 1. And whenever you're drawing, for example, let's do oxygen. How many valence electrons are in oxygen? How many? 6, because it's in group 6A. So whenever you're writing the Lewis dot diagrams for an individual element, you want to picture a box around that element. And we're going to put valence electrons singly, and then we're going to double them up. So 1, 2, 3, 4. I have to put 1 on each side. And this kind of just keeps them organized. And then we're going to double them up. Does it matter which ones I double up? Could I have 2 at the bottom? 2, it doesn't matter. Doesn't matter. Just keep it on the box, right? Don't draw the box, but keep it on the box, on the imaginary box. All right, stay inside the box. I don't normally say that to anybody, but I'm going to say it for this one. Okay, so I'm going to draw oxygens in a different color. I'm gonna do them in red. So I'm gonna go 1, 2, 3, 4, and just for fun, I'm gonna do it like that, okay? So now, what do I need to do in order to show how these atoms interact inside of a covalent compound? What are the electrons gonna do? They're going to be shared. We're no longer giving and taking, right? Now you have to be nice. Like, you know, your parents say you need to be nice to your sibling, you need to share, right? Okay, so covalent compounds need to share. So in order to have a bond, a covalent bond, you have to have one electron from one atom and one electron from another atom, and they're shared between the two. So we're going to take one dot, and we're going to turn that one dot from each atom into a bond. So now my oxygen is bonded to my hydrogen. I can do that with my other hydrogen. Now, if my structure is correct, all my elements have complete octets. Because that's the whole point of making either a covalent compound or an ionic compound, is to get an octet. So covalent compounds do it by sharing. So pick an element. We're going to start with hydrogen. We're going to count how many electrons are around hydrogen. And you have to count those shared electrons. So anytime you see a line, that counts as how many electrons? 2. Okay, so hydrogen. How many electrons are around hydrogen? How many electrons? We only have this right here, right? So how many electrons is that? 2. Are we good? We actually are. Why? Hydrogen's happy with a duet, right? Hydrogen and helium are happy with a duet. Check my other hydrogen. It has 2. So it's good, right? Okay, now let's count oxygen. So I'm going to start with my bonds. I have 2 here, 2, 4, 6, 8. Is hydrogen happy? Yes, it is. So I would actually draw that one more time, just so that I had a nice pretty diagram. I knew what was a line and what was a dot. Now, the way that I taught you in the video was to do needed, available, shared. And I'm telling you, needed, available, shared will work for everything. It's like magic. It's like chemistry magic. It's great. So let's do A again. I know it's kind of a pain, but let's do it again. Needed, available, shared. Okay, so you add up the needed number of electrons in your molecule. Then you find your available electrons. And that difference is what's going to be shared. So what does hydrogen need? Does it need an octet? No. What does it need? A duet. So here I have 2 hydrogen atoms, and those 2 hydrogen atoms each need 2 electrons. How about my oxygen? How many oxygen atoms do I have? I have 1. Unpin this, get myself some more room. I don't even know how to get rid of that. Ooh, there we go. Okay, and how many electrons does oxygen need? It needs 8 electrons. What's my total? $12. But do I have 12 available? That's what everybody wants. But do I really have that? Let's check and see. Available. I have 2 atoms of hydrogen. How many electrons are in each atom of hydrogen? Valence electrons, the ones that are available for bonding. How many? I only have 1 electron. How about oxygen? I have 1 atom of oxygen. How many electrons? Look in what period is, what group is oxygen in? 6A, so it has 6 electrons. So what's my total? 8 electrons. So the difference between what I need and what's actually available tells me what I'm going to share. So what's 12 minus 8? I have 4 electrons that are going to have to be shared. But sometimes it's easier to think in terms of bonds. So I'm going to divide by 2, and I'm going to get 2 bonds. Now, I had 8 available. So if I take my available minus my shared, I'm going to know what's left. So I started out, I had 8 electrons available, minus the 4 electrons that I shared. How many electrons do I have left? I have 4 electrons left. So when I go and do this, if I can scroll down, down. Okay. So if I have 4 electrons left, that means that I'm going to have 2 lone pairs somewhere on the molecule. So if I have 2 hydrogens and 1 oxygen, and I'm going to put in 2 bonds, should I put valence electrons on hydrogen? No, it's got a complete octet. It's good to go. How about oxygen? Is oxygen happy? Nope. It only has 2 4 electrons, right? So let me erase that. Oh, really? Okay. So I had oxygen, hydrogen. So oxygen's not happy. So I'm going to put my 4 electrons on oxygen. Is it happy now? I have 2 lone pairs, so that's 2, 4, and then 6 in one bond, and then 8 in the other bond. Okay? Both ways you get exactly the same result. Whatever you like to do is up to you. Okay? All right, so let's do B. After all that, just for water. C3H8. All right, so let's do needed, available, shared. How many carbons do I have? 3. How many valence electrons does carbon need? It wants how many? 8. Plus I have 8 hydrogens, and hydrogen wants how many? It wants 2 for a total of how many electrons? 40. Available. What do I do? 3 carbons. How many electrons in carbon? 6? Not 6. 4. So 3 atoms, and I have 4 electrons. Okay, I still have 8 atoms of hydrogen. How many does hydrogen have? 1 for a total of 20. Y'all get y'all calculators out. It's okay to use a calculator. All right, 40 minus 20 is 20. So I need to share 20 electrons. How many bonds is that? 10 bonds. If I look at what I had available and subtract out what I had shared, it's going to tell me what's left. I started out with 20 available. How many did I share? How many did I share? 20. What's left? 0, nothing. So let's draw our structure. Is hydrogen going to be a central atom? No, so we got to put our carbons. I'm going to have to bond our carbons together. So that's 2 of my bonds. Now what else do I have? 8 hydrogens. Let's try to put the hydrogens around the carbon to give all of the carbons complete octets. So that was 2 bonds, 3, 4, 5, 6, 7, 8, 9, 10. So we're just going to stick hydrogens all over our carbon. Does each carbon have a complete octet? Yes. Does each hydrogen have a complete duet? Yes. All right, I'm out of time for today. Y'all need to practice this. There are extra practice problems at the end of the chapter, and the answers to the odd numbered ones are in the back of the book. So if you want those extra questions with the answers, go to the back of the chapter, like the end of the chapter, and you have the answers there. Good to see you in class. You feel good? Yeah. What? Oh, yeah. Oh. I don't blame you. It's good to see you.
So I emailed you about the chapter thing. So it changed twice. So it's saying that now. But then you go into it and it's saying 0% for these, right?
But then what is the check mark telling you?
That's what I'm saying. Right, I did. And if you go into it, I completed it. So I'm so confused. Like this one's wrong.
Yeah, see, that's what I was like, it's not making sense to me.
Yeah, like I don't know what to do.
So can you keep the touchscreen?
Yes.
Okay. So you have one that's not done. What I'm gonna go in is I'm gonna overwrite, and I'm gonna give you, it's our 20 points for the 20 questions, so 19 out of 20.
Yeah,
I'm just gonna go in and overwrite.
Because I was like, well, I did it, and you hadn't even given me extra
And
time.
and I can see that it's done. But it's counting it wrong.
Yeah.
I don't understand. So I don't know if maybe you were seeing it differently than I was seeing it.
No.
But that's fine. I'm gonna go in and change it to a 19.
Thank you.
If I don't do it in the next 24 hours,
I will. Thank you.
here's my,
I wanted to click that I was present.
okay.
But I answered the question.
So it'll show that you were here. It just won't tell me if you were present in the classroom or on Zoom.
Okay.
So it's fine. That's
Okay.
okay.
I just didn't know.
How you doing?
Thank you.
Yeah, no problem.
Doing fine. How are you?
Good. How are you?
I'm good. I'm meeting with Andre and preparing another wedding. My son's getting married next June. Congratulations. You doing good? You're here now. Right? This is awesome. That's great. It's a challenge. But we can everybody sit down. Start feeling you're done. I'm thinking that we should put them down. Just to do it.
Is anybody still on who had a question? Anybody on the Zoom meeting? Let's see. Caitlin, you got a question? I see you stayed on. Okay. I'm guessing you don't have a question. You're just like me and you forgot to turn it off. So I'm going to go ahead and end the Zoom. Okay. Maybe I'm going to end.